Welcome to the high availability overview. So this is the second video in our series. And really the focus is going to be on high availability at a virtual machine level, at the SQL level, and also the service provider level. Let's just do a quick recap from the introduction video. If you haven't seen the introduction video, it's worthwhile looking at. It's around about 17 minutes long, but it really gives you a good introduction to it. If you haven't seen it, that's fine. Our SMS server is an enterprise-grade server that runs on Windows Server in your own cloud tenancy. So it's maximum security. So if you're a bank, financial institution, insurance company, federal, state government, etc., you don't want to be putting data out onto a service provider's network. The only data that should go onto the service provider's network, i.e. an SMS service provider, is the number and the message, no other data. And SMS aggregators, as they're known, like Message Media, Cinch, they have an obligation under the Telecommunications Act to protect the minimal data that you're sending to the mobile network. And in this design, it's just the number, the destination, plus the message itself. So this example on the right shows a simple implementation with a single server, applications and email talking to it, and out to a single provider. And it uses SMPP using TLS encryption over the internet. And then the SMS service provider, whether it be Telstra, Optus, Message Media, Cinch, etc., they then have the responsibility of delivering that to other networks and then ultimately onto the mobile network itself. So what clouds can this be used in? That's a logical question because it runs in your own cloud tenancy. So AWS, Azure. They're running others as well. They're running your own data center, running your own SQL server. The mix is there, but our focus in terms of QA and testing is Azure and AWS. So when we talk about high availability, what are we talking about? So we've got a Windows server. It runs inside a tenancy that belongs to you. Can run on Azure, AWS, doesn't matter. SQL Server itself. So SQL Server itself in your own tenancy may in fact run on VMware. We have a lot of enterprise customers who are still migrating their workloads and they feel comfortable with running their own SQL environment inside their own cloud tenancy, and that's fine. The more advanced customers in terms of their cloud migration, implementing Azure SQL MI managed instance, which is a platform managed by Microsoft, or in the case of AWS, it's the Relational Database Service, or commonly known as RDS. The connections to the SMS service provider, that's the other aspect of HA. So you've got to have HA at all levels. From the transport level to the SMS networks, SQL, which is where all the data is stored, and the Windows servers themselves. So let's move on and look at the examples of HA design. So for a simple proof of concept, there is no HA here. This is simply a single server with a SQL database with a single Windows EC2 instance. In this example, it's AWS, with an internet connection, and then the server establishes a connection over SMPP out to the internet. There is no connection from the external to the internal. So it establishes a two-way bidirectional SMPP connection. So it's outgoing from a firewall perspective. And then the bidirectional protocol for binds and transmits and deliveries and confirmations and incoming. That's the way that works. So let's look at a high available design for production and potentially for QA or pre-prod. So here we've got an AWS example, and again, same would be true for Azure. We've got two zones, one on the left, one on the right, both in the same VPC. We've got two Windows servers running on EC2, and we got AWS RDS in high availability design. And you'll notice there that the server on the right-hand side, and both of these servers are active. So if you want to consider in the old architecture designs from yesteryear, production's on the left, and DR's on the right, from a simplistic point of view. And each of these availability zones in public cloud work independently, but they also communicate with one another. So one of the key things we use is DNS, provided by Amazon. So, and what we do is we reconnect to SQL Server. If an availability zone goes down and RDS does the failover, we establish the connection within like 8 seconds. That's typically how long it'll take Amazon to roll over RDS onto the secondary availability zone. So you notice there's a dotted line between the second server on the right-hand side. So that would be the path it would take if it were using the SQL Server in the right-hand side. But on the left-hand side, both servers are accessing the current available SQL Server in that design. From the outgoing side, the Windows servers both communicate with, in this example, a single SMS service provider. That could be two SMS service providers, and we'll go into that on our next discussion. So what happens if AZ on the left goes down, which we can think about as prod? So it's gone down. So EC2 has gone down, RDS has gone down, Amazon detects it, fails over SQL onto the right-hand side. So now we've got that solid line. So the Windows server on the right-hand side, software says, okay, I cannot access SQL. I'm now going to reestablish a connection, and it uses DNS to do that. So Amazon have updated the DNS in the second zone and established a connection with SQL. And yeah, we've tested all that and that all works fine. The way we simulated that with AWS was we just rebooted RDS with a failover option. And we've got a second video that will cover that as well. SMPP TLS will always be connected through its own internet connection on that AZ on the right-hand side. So even though the internet connection on the left-hand side goes down, we don't use that one. So in the design, it's important to have HA at all levels. So you've got the SMS service provider level, you've got the internet level, you've got the zone level, you've got the Windows server level, and the SQL server. So now let's get into something a bit more technical. So here we've got a primary SMS service provider on the left-hand side, and we've got the same SMS service provider primary on the right-hand side. You'll notice they're both using the same account 1. So account 1 is the SMPP account credential that both of these servers are using to connect to that primary. So in this example, that could be, say, Cinch or Cinch Message Media. SMPP TLS encryption is used in all cases, whether it's primary or backup. That's just a given. So on the left-hand side here, we could have an instance where we have configured a secondary or a backup SMS service provider. In this example, provider 2. That uses another account, and we've given the example here, account 2. And it would also have a corresponding backup over on the right-hand side as account 2. This means in terms of HA at the carrier level or the service provider level. So what it means is that if the primary SMS service provider goes down, the software will automatically detect that, and within 10 seconds, it will switch over to the backup. And it will transmit using the backup SMS service provider the outgoing traffic. Now, obviously, any incoming traffic from the primary will not flow through because there will not be a receive bind to it. There's not much we can do about that. The main thing is, can we output messages? Can we send critical SMS messages out to the public? That is our primary goal here. So that backup SMS service provider, if we think about the alpha sender ID, so the alpha sender ID could be something like BNS as the sender, and that would appear on the phone. What happens in this case is that you can configure the primary SMS sender ID as BNS, and you can also have the second backup server also as BNS. So the customer receiving the SMS message will continue to see BNS. Now, in Australia, there are changes that are going to be implemented 15 December 2025. So this video was recorded in September 2025. So all customers are making sure that their alpha sender IDs are registered with one or more SMS service providers. So if you want high availability, you've got to register the alpha sender IDs with both providers. If you've got a two-way SMS capability, then this software is designed to use a dedicated sender number, a real number, just called an MSISDN, using that one for service provider 1. And when it fails over, it's got a matching, it's another number, it's a dedicated number provided by the backup SMS service provider, but it uses that one. So if you've got, for example, SMS service provider 1 has got a number 0412111111, and when it flicks over to the backup, it might be 0413222222. So for the customer response on the backup service, that response will come in via the backup service provider. Now, the important thing here is in a HA scenario, both the primary and the backup SMPP binds are both active. So what happens after, say, 10 minutes, what happens if the primary comes back online? They had a glitch. What this software does is it will automatically check every 10 minutes or so and say, is the primary backup? If it is, it will flick back to the primary and then start to recommence transmissions using the primary SMS service provider. And of course, any inbound messages will come back via the primary for the primary allocated MSISDN. Now, if a customer responded to a message that went out using a two-way number on the backup, what would happen to it? Well, the customer replying from their phone to the number associated with the backup would come back via the backup SMPP connection, and it would flow straight in. It would flow straight in because the receive bind is always up as long as the service provider is up. So you will continue to have two-way responses across both primary and backup as part of a HA design. So that's quite important to understand how that works. It's not as though we shut down the backup. It's always on. And it's always on for incoming. And it's always on for any confirmations and delivery receipts. So it's pretty detailed, but that's the level of design that you need to consider when you're implementing a high available SMS architect and high availability across all three layers. So SMS provider layer, Windows Server layer, and SQL Server layer. All right, well, that's about it for today. So thanks for joining on this video, and we'll see you again sometime.